Yeah, can you see my screen?
Yes, sir.
Okay. Okay. Now can you see the assignment?
Yes, sir.
Okay. So let's start. So today I will discuss the assignment 7 from the previous run course of this MA 49. So let's start with the first question. What is saying? So it's given that the length of the curve of the parameterized, the curve is parameterized by this x equals to cos cube t and y equals to sin cube d in the range where t lies in 0 to pi, right? So this is a curve with, these are called parameterized curve. With this parameterization is given by cos cube t and y equals to sin cube d, and t belongs to 0 to pi, right? So for the parameterized curve, what is the length? So its length is given by length of the curve is given by integral from 0 to pi. It will be here, it will, if it is a to b, means in general the definition is a to b, and the modulus of square root of x dash t whole square plus y dash t whole square, right? So this is the integration with respect to t. So this is the formula for length of the curve. So here x and y is given, they are function of t, so we have to just put it there and compute the integral. So we have what happens? So it will be from 0 to pi, integration from what will be x prime t. So x prime t will be 3 cos square t, right, into minus sin t whole square plus what will be the differentiation of this y with respect to t? It will be 3 sin t sin square t into cos t, right, and whole square, integration with respect to t. So you have to evaluate this, right? So first simplify this 0 to pi. If you simplify this, you can see that 3 are both common and sin and cos also common. So, and if you, so 3 square is 9, if it's come out from the root, so it will be again 3, and sin square cos square take the common out, so it will be sin t into cos t. Inside root for the first, from the first square, the remaining term will be cos square, and from the second it will, remaining term will be sin square t, right, dt. And so sin square plus cos square t is 1, so you get 0 to pi, it will be sin t cos t, right, dt. So we get this, and modulus is there, sorry, because it may be negative, right? So that's why we have to take the modulus. Here we have to take the modulus, because length cannot be negative, so that's why you have to take the modulus. So here the modulus is there, right? Now how to write it there, how to integrate? Just write 3 by 2, and so integration 0 to pi, it will be modulus of sin 2t, right, into dt. Now you can see that, so this is the curve, you can see 0, pi by 2, pi. So when from 0 to pi by 2, sin 2t, if you plot the sin 2t at the point, so sin 2t at t equals to pi by 2, it's 0, right, because it will be sin pi. So this will look like this. and again 2 pi it will be look like this. So this is the curve for sine 2t. At the point pi by 2 it will become 0, right? So from 0 to pi by 2 it is positive, and pi by 2 to pi it is negative, right? And as there is modulus, so you will divide it, so it will be sum of these two. From 0 to pi by 2 it will be sine 2t is positive, so that's why it will be sine 2t, because they are on 0 to pi by 2. Sine 2t is positive, right? This is greater than equals to 0, and on pi by 2 to pi sine 2t is negative, right? So therefore if you do the modulus, you will get, you have to put the minus, right? Minus of sine 2t will be positive, so that's why it will be from minus pi by 2 to pi it will be negative sine 2t dt, right? So we have to do this. So it is 3 by 2, so 0 to pi by 2. Oh, note that, so first we will evaluate this integral. So you can see that this integral will be same as this. So first look at this. So note down this note here. What is this integral? Integral pi by 2 to pi, we are doing this sine 2t dt. So make the change of variable. So put t equals to pi by 2 plus s. Then what happen? When t equals to pi by 2, s will be 0. So this will be minus of 0 to pi by 2, right? When t is pi, s will be pi by 2, right? And it will be sine 2 into pi by 2 plus s, and it will be ds, right? So minus 0 to pi by 2 sine pi plus 2s ds, right? So sine of pi, right? Sine of pi something, what happened? It will be again minus of sine, right? So that's why minus we will get, this is sine 2s ds, right? And this is same as, we can change the variable, right? Sine pi by 2 sine 2t dt, because this is the dummy variable. So we get this, right? So this is, we get this, we write it star. So from star, so we get this minus of pi by 2 to pi sine 2t, this is same as 0 to pi by 2 sine 2t dt, right? So this is the first remains same, sine 2t dt, and minus of sine 2t we get, this is again 0 to pi by 2 sine 2t dt, right, by star. So we get 3 by 2, this is 2 times because both are same, so we get 2 into 0 to pi by 2 sine 2t dt, right? So we get 3 times, and what will be the integration sine 2t? It is minus of 1 by 2 cos 2t, right? And now you have to evaluate from 0 to pi by 2. So 3 by 2, and if you put pi by 2, cos pi is minus 1, right? So minus is there, cos pi is minus 1, minus cos 0, it's 1, right? So we get this, so means, so we get 3, right? So we get this integration is 3, means the length of the curve is 3 we have got. So which option is correct? Option number 2 is correct, right? Is this fine, the computation? Yes.
Yes, sir.
Okay, so let's move to the next one. So last one is the parameterized curve, right? So for the parameterized curve we have done. So second one is what is saying, the length of the curve where it's given in terms of y is some function of x, and you have to find the length of the curve from 0 to 1. So for this type of curve, whenever it will be some function of y equals to f of x, so then length of the curve is given by length of the curve is given by integration a to b 1 plus dy by dx its whole square and integration with respect to dx. Again you have to take the modulus so that it is non-negative, right? Because length is always negative, positive. So the length of the curve is the length of the given curve y equals to square root of 1 minus x square is what, from 0 to 1, integration will be, limit will be from 0 to 1, what happened, modulus of square root of 1 plus dy by dx whole square, right, dx. So just find what will be the dy by dx, y is square root of 1 minus x square. What will be dy dx? So first if you do the differentiation, it will be this to the power half, right? So half, so 2 will be comes out, it will be minus, means 1 minus x square, and if you do the differentiation of, it will be minus 2x, right, this. So you will get x by square root of 1 minus x square, right? So this is the derivative, dy dx, we got this, minus is there. So now if we put it here from 0 to 1, modulus 1 plus square of this, means it will be x square, x minus x by square root of 1 minus x square whole square and dx. So this is, means if you simplify it, so just take the positive square root, means taking the positive square root, we get this is 1 plus x square by 1 minus x square, right, dx. So this is, now this will be same as 0 to 1, 1 minus x square, 1 minus x square plus x square dx. So this will be 0 to 1, it will cancel out 1 by 1 minus x square dx, right? So we get this. So now check which option is correct. So we get integration 0 to 1, 1 by square root of 1 minus x square dx. So which option is correct? Option D, right? 0 to 1, 1 by square root of 1 minus x square dx. So the length of the curve is given by this integral. Is this fine? Okay. So now move to the next one. Question number 3. What it is saying? A solid object is made by rotating the area between the y equals to 2x square and y equals to x plus 1 with x greater than equals to 0 around the x axis. So draw it, how it will look like. So first draw y equals to 2x square, it will look like the parabola, right? Y equals to 2x square, so this will look like this. And y equals to x plus 1, how it will look like? At x equals to 0 it is 1, so it will look like this. So this will cut by this and this will be, right? So this is the curve y equals to x plus 1, and this is the y equals to 2x square. So a solid object is made rotating the area between these two, means and with x greater than equals to 0. This is the 0 and this is the x axis. So you have to take only the positive part, mean this part you have to take, right. So you have to find the volume which will generate. So if you rotate, now rotate it like this. So if you rotate this, it will generate a volume, right, because this is the area. So if you now rotate it with respect to x axis, you will get a volume, right. So you have to find the volume of this solid, right. So for this, whenever it will rotate with respect to x axis, so the volume is given by volume, it will be given by integration. Suppose it's from a to b, it is given by pi y square dx, right. And whenever if there is two curve, then how the volume will look like, means if you do with y some y1 curve, then it will give the volume in below the curve, right. So and if there is two curve, if you find this, if you subtract the this one from the lower curve, if you means what I am saying here, for two curve, for two functions, f and g, so volume between this, means between this, like this area, this is given by integration a to b pi. So first you have to f square and subtract it by, right, g square and dx. Suppose these are both a function of x, so it will be look like this, right. So in our case, what happened? So volume, so in our case, volume, so we have to find the limit, right. So you have to find this, we know this is the point 0, and you have to find this point where they will intersect, right. So from we will integrate from 0 to this, right, this point. So you have to find the intersection point, this point, right. So means where these two will intersect. So where these two intersect, means these two curve will get the same value, right. So if you do this, means whenever, so when these two will become same, sorry, so when means these two will be same, means x plus y, sorry, x plus y 1, x plus 1 equals to 2x square, right. When these two equal, we will get a solution, right. Means you have to solve 2x square minus x minus 1 equals to 0, or if you solve it, 2x square minus 2x plus x minus 1 equals to 0, or 2x, take the common out, x minus 1 plus x minus 1, right, equals to 0, or you get 2x plus 1 and x minus 1 equals to 0. So you get for the first one 2x plus 1, if it is 0, means you get, or x equals to minus 1, right, but we do not need this negative, we do not need where it will intersect. So we will take this one, x minus 1 equals to 0, or means x equals to 1, at the point x equals to 1 they will intersect. So this is the point we get 1 comma 0, right, and if you put this, we will get 1 comma 2. So this point is 1 comma 2, means if you put x equals to 1, y will be 2, right. So you have to integrate from 0 to 1, right, in this range. So the value of the limit, so this is the extra thing. So I am writing it here, it will be from 0 to 1 pi. So which curve is the, means above, so this y equals to x plus 1, this curve is above, right. So this is f and this is g, y equals to x square, this is the g curve. So it will be pi of x plus 1 whole square, right? Y square, this curve is the above, and so for the second one it's 2x square, right? 2x square whole square, subtracting it, and dx. So this will be the volume, right? Means pi x square 1, which it will be give this area, right? So this is the red one, this will be the entire red one, and if you when you integrate with respect to g, it will get this blue region, right? So the black region will be subtracting red from the green. So from the red means for pi of x plus 1 whole square, which will give the red region, and minus pi of 2x square whole square, when you are doing, we are subtracting the green region, when we will getting the black region. Now and then we revolve it, right? So we will get this. So we have to just evaluate this integral. So what happened then? 0 to 1 pi, how it will look like? X square plus 2x plus 1 minus 4x to the power 4, right? Dx. Now you can integrate this pi, integrate this out. So if you integrate this out, you will get x cube by 3 plus x square plus x minus 4 by 5 x to the power 5, right? And limit from 0 to 1. Now if you evaluate the limit, you get pi 1 by 3 plus 1 plus 1 minus 4 by 5. Yes. And now if you put the limit 0, you will get everything will be 0. So you will get this. So means pi. So we get, use this, simplify it, 15 5 plus 30 minus 12, right? 35 minus 12, it will be 23. So we will get 23 pi by 15. So this will be the volume generated by the area of this. So which answer is correct? 23 pi by 15. So means option 3 is the correct answer, right? Do you understand this? Is this fine?
Sir.
Okay. So this is done. Now move to the question number 4. What it is saying, that it is same, but now you have to revolving with respect to the y-axis. The region bounded by the parabola y equals to x square and line y equals to 2x in the first quadrant is revolved about the y-axis, right? So for that you have to find the volume. So again draw the diagram. So if you draw it, y equals to x square, it's the parabola this, and y equals to 2x, this line will be like this, right? So this is the y equals to 2x line, y equals to 2x, and this is the y equals to x square. So you have to find this region, right? So like as early, what you have to do, you have to first find this intersection point, right? So which point they will intersect? It's the 0, 0, and you have to find at which point they will intersect, right? Means you have to solve where they will equal, means 2x equals to x square, right? Or what happen, it will be x square minus 2x is 0, or x into x minus 2 is 0. So either x will be 0 or x will be 2. So at the point 0, 0, that we have got, and when it will be 2, y will be 4, right? So this point is we will got 2 comma 4. Now this is, now the solid will become revolving with respect to the y axis, right? It will revolve. So you have to take this range. So 0 to it's the 4, right? So you have to integrate with respect to this y axis. Now it's this time with not respect to the x, because we are revolving with respect to the y axis. So you have to integrate with respect to the y. Okay, and for the, if you view it from the y axis, which curve is means above the other curve? Y equals to x square is above the y equals to 2x when you view in from y axis, right? Because this is the above from the y axis. So what will be the volume in this case? So volume, it will be integration from limit will be 0 to 4, right? Because for the, because y axis we are rotating with respect to the y axis. So that's why I am taking 0 to 4, not 0 to 2. We do not take with respect to the x axis, right? And now you have to take pi x square dy for this time. Here the volume formula is, it will be integration 0 a to b pi x square dy, like this. So you have to put this x equals to, it will be means root y, right? This whole square minus x equals to, second curve it will be y by 2 whole square. And now you have to integrate with respect to the y, right? Because this time it's revolve with respect to the y axis. So you have to find this one. This will give the volume generated revolved by this area. Okay. So what will be this? 0 to 4 pi will come out. Yes. So it will be y square minus, oh sorry, y, it will be square, it will be y minus y square by 4, right, dy. So now do the integration, pi, if you do the integration, what you will get? Y square by 2 minus y cube by 12. And now you have to evaluate from 0 to 4. So first put the limit, upper limit 4. So if you put, you will get 16 by 2 means it 8 minus 4 cube by 12. It will be 64 by 12, right? 64 by 12. The minus 0, it will be 0. So we will get this. So pi. So this will be 8 minus 16 by 3. So if you simplify this, you will get 24 minus 16 by 3. So what is this? 8 pi by 3. So we will get the volume is 8 pi by 3, right? So which option is correct? Option A is the correct answer. Is this fine?
Yes, sir.
Okay. Let's come to the question number 5. So now you have to find the approximate value of the integral 0 to pi sin square x using the trapezoidal rule, right? So what is the trapezoidal rule? First I will write down what it means, how to find this. So suppose this denote, suppose you want to evaluate this integral a to b fx dx, right? So divide this interval a to b into partition, like a to b you are doing. So suppose this is denoted by x naught and x1 dot 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 xn, and this is xn minus 1, this is xn, right? So we divide it into partitions and write h equals to b minus a by n. Suppose you are doing n partition, so write the h will be b minus a by n, right? So then trapezoidal rule saying that this will be approximately equal h by 2. So this is this is h by 2 into f of x naught plus 2 into f of x1 plus dot 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 2 into f of xn minus 1 plus f of xn. So f of x naught and f of x1 there is no coefficient, and all other term from x1 to xn minus 1 there is a 2 in front of the, it means coefficients are 2. So trapezoidal is saying that if you find the area of this integral, means area, so it is approximately equal to this, right? So we will use this is called the trapezoidal rule. So we will use this technique to find the integral of 0 to pi sin square x dx. So here the fx is sin square x dx. Now you have to find, it's given that n is 6, so means you have to do the 6 partition, right? So n is 6 and a is what, 0 and b is pi, right? So what will be h? H in our case will be pi by 6, right? So this will be approximately equal to pi by 6, h by 2, right? 1 by 2 is there. Now x0 is what? So in this case x0 will be 0, right? What will be x1? 0 plus pi by 6, so means it will be pi by 6 and so on, and xn will be, the last point, which means x6 will be pi, right? So we will write it here. So if you write it here, it will be f of x naught plus f of 2 into f of x1 plus 2 into f of x2 plus 2 into f of x3 plus 2 into f of x4 plus 2 into f of x5 plus f of x6, right? This we have to find. So means pi by 6 into half. What is f of 0? Means x naught is 0, so means sin square 0, right? So this is sin square 0 plus 2 into sin square x1 will be pi by 6, right? This pi by 6 plus 2 into sin square again pi by 6 plus pi by 6, what happen? It will be pi by 3, right? Pi by 3 plus pi by 3 plus pi by 6 is pi by 2. 2 into sin square pi by 2 plus 2 into pi by 2 plus pi by 6 means sin square 2 pi by 3 plus 2 into sin square 2 pi by 3 plus pi by 6, it will be 5 pi by 6 plus sin square, last one will be pi, right? Means 5 pi by 6 plus pi by 6, it will give the value pi. Oh sorry, so this is exactly the equal, this line. So we will get pi by 12 sin 0 0, so this one is 0 plus sin pi by 6, what value? It's 1 by root 2, right? Or no, 1 by 2. So 1 by 2 is 1 by 4, 2, it will be get half plus 2 into sin pi by 3, it's root 3 by 2. If you square it, we will get 3 by 4, means it will be 3 by 2 plus it will be 2, and again it will be the by symmetry you will get 3 by 2 plus half plus 0. So if you put this value, you will get this. Now we will do this calculation, what it will be? So it will be 1 plus 3 plus 2, so means pi by 6, pi by, it will be 12 into 6 means pi by 2. So this, we get this integral means approximately equals to pi by 2, right? So the approximate value of this integral is pi by 2. So the fourth option is correct, right? Is this fine? Okay. Now come to the next one. 6. It is the true false question. What is saying? To estimate the integral a to b x square fx dx with Simpson's rule, the function f is approximated with saying the trigonometric function. Is it true or false? So you have to approximate this integral fx dx. So what Simpson's rules is saying? Suppose this is the interval a to b, and suppose some kind of function is there, and you have, suppose this is x naught, x1. In Simpson's rule you are doing the even partition. Suppose we are taking x2 and x3, and this is x4. So this point will this x1, x2, x3 and x4. So in Simpson's rule we are approximate with the quadratic functions. So means we will take some function which will be equal in these 3 points, and we will approximate. Again we will take this kind of function. So we are approximate this function. Suppose this is f. We are approximated by quadratic functions, right? So we approximated for Simpson's rule. We approximate f by this type of function. Quadratic functions means ax square plus bx plus c, this type of functions. So, and what are trigonometric functions? Means trigonometric functions are sine, in terms of sine and cos. These are called the trigonometric functions. Means trigonometric functions are in terms of sine theta, cos theta, right? Functions of this, polynomials of this. But we are not approximating by sine theta, cos theta, right? We are approximate by quadratic functions. So the option is false, right? We are approximated in terms of the quadratic function, not the trigonometric functions. So this is the easy. Okay. So this is done. So now move to the next one. It is again the true false question. So it's saying that to estimate the integral a to b fx ds with trapezoidal rule, f is approximated to the polynomial of degree less than 2. So what the trapezoidal rule is saying? If you want to approximate fx dx, and suppose this is the interval a to b, means there we will approximate. Suppose this is this kind of functions. Suppose x1, this is x naught, suppose x2, x3 and x4. Yes. So there you will approximate the functions by linear functions, by this kind of, means 1 degree polynomial, right? Linear polynomial. So this is f. So you are approximate for trapezoidal rule. We approximate f by linear functions, means ax plus b, this type of functions. Right, and this has degree 1, right? So it is the, and it is again polynomial of degree 1, less than 1 or 1. So here it is saying that to estimate this in trapezoidal rule, the function f is approximated by the polynomial of degree less than 2, right? So here we have approximated by degree 1, right? So it's true because it is the degree less than 2. So this is question number 7 is done. Now move to the question number 8. So what it is saying, use the Simpson's rule with n equals to 4 to approximate this integral and approximate up to 2 decimal digits, right? So you have to approximate this with respect to Simpson's rule. So first write down what is the Simpson's rule. If you want to approximate this a to b fx dx, so as I am telling that for in Simpson's rule, you have to do the even partitions, x naught, so this is the a and this is b, means xn. So you have to do the even number of partitions, this x1 xn minus 1, n is even, so then this is approximately equals, suppose again the h is here is same, b minus a by n. Then what Simpson's rule is saying, this integral is approximately equal to h by 3 f of x naught plus 4 into summation. For the odd terms there will be coefficient will be 4 and j equals to from 1 to n by 2 f of x 2j minus 1 plus 2. For the even terms coefficient will be 2, because these are odd terms, right? X 2j minus 1. For the odd coefficient will be 4, for the even coefficient will be 2, n by 2 minus 1 f of x 2j plus f of xn. So this is the Simpson's rule, right? So you have to use this to find the approximate value of this integral. So integral 0 to 5x to the power 4. How to here what is the h? Because here b is 2 minus 0 by n is 4, so it is half. So h by 3 it will be 1 by 6. And now what are the points? So f of x naught means f of 0, right? So f of 0 plus f of, for the 0 plus half it's half, plus f of 1, for the odd case 4 is there, right? Coefficients 4 is there because it is x1. So 4 f of half plus even when it is x2, so this is f of 2 f of 1 plus again it will be 4 f of 3 by 2 because it's odd, and now xn will be f of 2. So this is approximately equal, not equal. So this integral is approximately equal to this. Now put this. So here x naught is 0, x1 is half, x2 is 1, x3 is 3 by 2, x4 is 2, right? So what is f0? Function is 5x to the power 4, so it is 0 plus 4 into, if you put half, what you will get? You will get 5 by 2 to the power 4, it is 16, plus 2 into, it will be 10, plus if you put 3 by 2, what you will get? It will be 405, I think, 405 by 4, plus if you put 2, you will get 80, right? So if you do this computation, what you will get? You will get, it will be, I am writing it down, you will get 770 by 4. Now if you compute it with respect to what it is saying in the approximate up to 2 decimal digits, right? So if you approximate it with respect to 2 decimal digit, you will get 32.08 up to 2 decimal digit. So we get this integral is approximately equal to 32.08. So now check which option is correct. 32.08 is option number 3, right? Is this fine? Okay, if no question, let's move to the next one. Question number 9. What is saying that a sequence is given xn equals to 1 plus 1 by n whole to the power n. You have to find where this will converges to this, right? So this is how to write this. So you have to find the limit. Sorry, I am writing it, limit n tends to infinity of this, right? This you have to find. So this, just expand this by in terms of binomial expansion. So what happens if you expand it? It will be 1 to the power n plus nc1 into 1 by n, right? Plus nc2, it will be 1 by n square plus dot dot dot. The last term will be ncn 1 by n to the power n, right? So by binomial expansion. Right. So now what happens? So if you calculate this nc k terms, so 1 plus nc1 is n, right? So n into 1 by n plus nc2. What is nc2? It's n into n minus 1 by 2 into 1 by n square plus the next term is will be nc3. So what it will be? N into n minus 1 into n minus 2 by 3 factorial. It will be, right? It is 2 factorial we will get, and 1 by n cube will be there plus dot dot dot. If you do so, we will do this up to ncn you can do. So now, so the second term it's n by n, it's cancel out, so we take it out 1, and these first two term we take it out, plus limit n tends to infinity. It will be, you can divide it by n. So first one it will be n and 1 minus 1 by n, right? If you divide this, n will cancel out, in n minus, it will be 1 minus 1 by n, right? Into 1 by 2 factorial plus, now divide by n cube, what you will get? 1 minus 1 by n, 1 minus 2 by n into 1 by 3 factorial plus do this like this. So now you can check, as n tends to infinity, 1 by n goes to 0, right? So this is 1 plus 1 plus, as n tends to infinity, this term will goes to 1, so we will get 1 by 2 factorial plus these terms all, first 1 minus 1 by n also goes to 0, 1 minus 2 by n goes to 1, 1 minus 2 by n, this will also goes to 1, so we will only remain 1 by 3 factorial plus, you can check that for the similarly hold for up to n terms, right? Means, and as n tends to infinity, it will be infinite sum, so it will be dot 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 like this, right? So now, so what is this? So you can write it by as k equals to 0 to infinity 1 by k factorial, right? Because at 0 factorial is 1, 1 factorial is 1, so we get this series. So now this is well known series, right? So we know, so this is called, this is the value of E, right? What is the E? E is the series, this series, right? K equals to 0 to infinity 1 by k factorial, means 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus dot dot dot. So we get this sequence converges to E, right? So which option is correct? Option number 3rd. right? Is this fine?
Yes, sir.
Okay. So now move to the question number 10. Again here you have to find the sequence xn where it will converge, means for which values of a. So xn is given a to the power n plus 1, for which values of a this sequence will converge, right? So we'll first choose a equals to 1. So then what happen? So xn, how this sequence will look like? Everything will be 1, right? If a is 1, everything will be 1. So where this sequence will converge, because this is a constant sequence once, right? So this will converges to, so xn converges to 1, right? So for a equals to 1, this sequence converges. Now take a equals to minus 1. What will be the sequence for a equals to minus 1? When n equals to 1, it will be 1. N equals to 2, it will be minus 1, right? So it will be 1 minus 1, 1 minus 1. So this is oscillates, right? 1 and minus 1, 1 minus 1. So it does not, it is not convergent, right? It was also done in the class, I think. It is oscillator sequence. So 1 minus 1, this sequence does not converge. So does not converge. Or you can view it as a two subsequence, right? 1 and minus 1, these two subsequence, they will both converge. So it does not have a unique limit point. So it does not converge. Now, so for 1 a equals to 1, it will converges to 1. 1 a equals to minus 1, it does not converge, it oscillates. Now check for a equals to a greater than 1. What happens is if a is greater than 1. So if a is greater than 1, then note that you can write a equals to 1 plus k, right? Where k is bigger than 0. Now what happens if you take, or if you take a to the power n plus 1 or a to the power n, just take, then what happens? It will be 1, means 1 plus k whole to the power n. So if you expand binomial, you will get 1 plus nk plus nc 2 into k square, right? Like this. So we will show that this for a equals to 1, this will diverges, right? Now means to show diverges, a sequence xn is diverges to infinity if for any m positive number there exists n belongs to natural numbers such that xn should be greater than m, right? For all n, and this is for all n greater than n, then we said that xn diverges to infinity. So you have to find such m, find such capital N, right? So we will make this to be, so this is, each term is positive, so we can write it, this is greater than 1 plus nk, right? So for given, now what we will choose? So given m greater than 0, take this, right? 1 plus nk, choose this greater than m, means then nk will be greater than m minus 1. Take m greater than, m large number greater than 1 we will take also. So n greater than m minus 1 by k, right? So for large number, for large m, means take greater than 1, choose n, capital N, capital N equals to this, you can choose, right? M minus 1 by k, greatest integer plus 1. Then what happened? So if you choose this n, then what happened? 1 plus nk is greater than m, means a to the power n, a to the power n, this is greater than 1 plus nk, right? So 1 plus nk is we are choosing greater than m, means this will be greater than m. So this will be greater than a to the power m greater than m for all n greater than this n, right? So implies, so then a to the power n plus 1 will also be diverges, right? Because a is greater than 1. So it will also also means from here you can say, so a to the power n is divergence, right? So a to the power n diverges to infinity. So if a to the power n diverges to infinity, implies a to the power n plus also diverges to infinity. So what we get? If a is greater than 1, then a to the power n, this sequence diverges to infinity. So xn does not converge for a greater than 1 also, right? Now we will check this for a greater than minus 1, a less than minus 1. So a less than minus 1, this case. So means if a is less than minus 1, then, so if a is less than minus 1, then you can see that mod a, what happened? Mod a is less than minus 1, right? Or no, sorry, if a is, or for this case you can do it like this, a is less than minus 1, then you can choose these two sequence, right? Choose x to n, then it will be a to the power 2n plus 1, right? So as a is negative, so a to the power 2n plus 1, it's odd number, so it will be also less than 0, right? And take this subsequence x to n plus 1, so a to the power 2n plus 2, right? Because xn is a n plus 1, so this is the, so a n plus 1, this is whole square, right? So whatever a, it will always positive, right? So for even sequence x to n, it is negative, x to n plus 1, it is positive, right? So xn oscillates, means it will not converge, right? It oscillate, implies xn does not converge. So for a less than minus 1, the sequence also does not converge. Now so the remaining case is remains a is lying between, now the remaining case a is lying between minus 1 and 1. So this is the remaining case. So meaning so this is the same as mod a is less than 1, right? Or this is saying means if a is 0, then nothing to do, right? If a is 0, then the sequence is 0. So take 1 by a, which is greater than 1, whenever a is not 0. If a is 0, then the sequence xn is 0, right? This is the 0 sequence. So this will converge to 0. So we are taking a not equals to 0. So then 1 by mod a is greater than 1, if mod a is less than 1, right? So now the third part, so for a greater than 1 case, we saw that if a is greater than 1, then the sequence diverges, right? So as 1 by mod a is greater than 1, so 1 by mod a to the power n, this sequence diverges by the third case, right? Of a greater than 1, right? So by the third case, applying the third case to 1 by mod a, we get 1 by mod a to the power n diverges, means 1 by mod a to the power n, it is diverges, or 1 by mod a to the power n plus 1, it is also diverges. So if you do the, so what happen if 1 by mod a to the power n plus 1 goes to infinity, means mod a to the power n plus 1 goes to 0, right? So we get in this case, so this is means that a to the power n plus 1, this goes to 0, or this is the sequence, right, or the sequence converges to 0. So in this case, whenever a is lying between minus 1 and 1, the sequence converges to 0. So among three cases where this will converges, for x equals to 1 this is convergent, this does not converge. A greater than 1, here it also does not converge. A less than minus 1, it also does not converge, and when a is lying between minus 1 and 1, it converges, right? So what happen, we get a equals to 1 and a lying between minus 1 and 1, the sequence converges. So what we get, xn, this sequence a to the power n plus 1 converges when minus 1 less than a less than equals to 1, this, right? So in this range of a, the sequence converges. So now check which option is correct. So the first option is correct. For a lying between minus 1 and minus 1 less than a less than equals to 1, the sequence converges, right? So means this option is correct. Is this fine? Is this fine?
Yes, sir.
Okay. So the assignment is done. Any other questions or any doubt from this assignment? Yes. Any doubt?
No, sir.
Okay then. So let's stop for today. If there is no doubt, let me stop the recording.